Let's learn how to solve practical problems in Trig. Now, before we get to any solving, we're going to need to cover a bit of terminology first. So let's see what we have going on over here. We have a person A. When A looks straight ahead, that level is called the horizontal. Now, if there's an object above or below A, when A looks directly at these objects, that is called the line of sight. So let's look at this plane first. Whenever A observes an object above, such as this plane, the angle between the line of sight and the horizontal is called the angle of elevation of the object from A. Okay, so this little angle over here, that's called the angle of elevation. Now when A is observing an object below, such as this boat right over here, then the angle between the line of sight and the horizontal is called the angle of depression of the object from A. So this angle over here is called the angle of depression. So now that we got the theory out of the way, before we go and do some practice problems, I just want to go over the strategy that we'll be using today, because it's very important to know what we're doing. We don't want to just do a bunch of problems without understanding what we're trying to do. So there are 3 rules that you should follow, and if you follow these and do them correctly, then you should be able to solve every trig problem in this video and every problem your teacher may give you. So we're going to get a lot of practice just using this strategy over and over again. So your first step will be to draw your triangle. Because what's going to happen is your teacher is most likely going to give you a problem that is not already drawn out for you. So you need to take the problem and transform it into a triangle. And I'm going to tell you right now, it's going to be a right triangle. So something like this over here. Because a lot of times we're going to be concerned with objects that are standing perpendicular to the ground. So something like a building or a cliff or a flagpole. It's not exactly leaning on an angle. It's just standing perpendicular to the ground. The next step is to fill in your givens. So any sides you're given or any angles you're given. So you could be given this side or maybe this side. Most of the times you won't be given this side. And in terms of angles, you might be given this angle or you might be given this angle. And since this angle is always a right angle, that's not super important. It's mainly these 2 angles that we're concerned with. And then the final step is to use basic trig ratios to find what you're looking for, the unknown. And just as a review, your basic trig ratios are going to be SOH, CAH, and TOA. Now I'm not going to go over SOH CAH TOA in this video because that's actually a prerequisite to this video. So if you don't remember those, you should review those before watching this. And it's really important to really know this because this is how you're going to find your unknown. And I'm going to tell you right now, most likely, probably 9 times out of 10, you're going to be asked to find this side or this side. Because when you think about it, they have the most use in everyday life. A lot of times, we're concerned about how far away we are from something or how tall something is. Most of the times, you won't be too concerned with the longest length, the hypotenuse, but occasionally there will be a problem involving that. So we're still going to cover one problem involving the hypotenuse, but as you'll see, most of our problems will be concerned with these two lengths. And then in terms of angles, as I said before, these two angles are the most important because we're mostly concerned with the angle we look up at something or the angle we look down at something. And this angle is always a right angle. So really just cement these 3 points into your brain. We're going to go over those in all the problems. And at the start, I might emphasize these 3 steps quite a bit, but that's just so you really get it in your head. Later on, as the video progresses, I probably won't be going over each step every single time because by that point, I would like you to already be used to it, right? It's already a habit. So yeah, that's the strategy. I know this theory and strategy part might be a little boring, but it is necessary before we go on to the practice problems. But with that out of the way, write this down, get it in your head, because now we're going to move on to the first problem. So let's check it out. So the first common example your teacher will probably give you is a setup something like this. So given that we're standing 599 meters away from the Eiffel Tower and the angle of elevation is 26.6 degrees, we need to find the height of the Eiffel Tower. So we're going to follow through the 3 steps that we always do to solve these trig problems. So our first step is to take this diagram and turn it into triangles. So what do I mean by that? How are you going to take this and turn it into triangles? Well, firstly, I would say that there are 3 important points. We have this point where we are, the top of the tower, and the bottom of the tower. So I'm just going to fill those in. And then we're going to make a triangle. Now the next step is to fill in our givens. So any sides were given, any angles were given. So we are given a side, the distance from where we are to the base of the Eiffel Tower is 599 meters. That hasn't changed. And then the angle of elevation is 26.6 degrees. And since we're trying to find the height of the Eiffel Tower, which is this side over here, we can just go ahead and call that H. H for height. You could also have done E for Eiffel, maybe P for Paris, T for tower. Doesn't really matter. Just use a variable. And now it's time to use basic trig ratios to solve for the unknown, also known as H in this example. So we have an angle and we have 2 sides. We have this side and this side. Now, relative to this angle, this side would be the adjacent side, and this side would be the opposite side. So what trig ratio relates the opposite and adjacent side? Well, that would be tangent. So tan of 26.6 is equal to, remember, TOA means opposite over adjacent. The opposite side is H, and the adjacent side is 599. And now, to get H, which is what we're trying to find, all we have to do is multiply both sides by 599. And we'll find that the height is equal to 599 times tangent 26.6. And if you put that into your calculator, you'll find that it turns out to be 300 meters. Don't forget your units. On to the next problem, where we have a lifeguard and a swimmer in trouble. So once again, to start off, we're going to take this situation and turn it into a triangle. So our 3 important points would be where the lifeguard is, where the swimmer is, and the point directly above the swimmer's head and level with the lifeguard if they were to look straight. So it would look something like this. The next step is to fill in our givens, so we know that this angle of depression is 14 degrees. We also know that this vertical distance is 3.7 meters. And we're trying to find this horizontal distance. So let's call that x. So this problem is slightly different from the previous problem. In the previous problem, we had an angle of elevation and we were given a horizontal length and we had to find the vertical height. But in this problem, we're given an angle of depression, a vertical length, and we need to find the horizontal distance this time. And now that we have our triangle and we filled in our givens, now it's time to bust out the trig. So we have this angle, and relative to this angle, we have its opposite side and the adjacent side. So what trig ratio relates the opposite side and the adjacent side? Well, that would be tangent once again. So let's just write that out. The tangent of this angle, 14, is equal to its opposite side, which is 3.7, over its adjacent side, which is x. And all we have to do is find x. When we rearrange that, we'll find that x is equal to 3.7 divided by tan 14. You could get your calculator out and it'll turn out to be a distance of 14.8 meters. Jack and Rose are in love, so of course they're staring at each other. So they're standing a horizontal distance of 0.8 meters away from each other, and the vertical distance between them is 1.3 meters. And we need to find this angle of elevation. So once again, same thing. Let's start off by taking this and turning it into a triangle. In fact, you can already sort of see the triangle running along there. But we're going to take this and move it here, maybe draw it a little bigger as well. Something like that. Let's fill in what we know. We know this side is 0.8 and this side is 1.3. And we need to find this angle. So if we need to find this angle, well, relative to this angle, we're given an opposite side and an adjacent side. So once again, this is tangent. But unlike the previous problems where we were given the angle, so it was an actual number, this time we need to find the angle. But we could still write the tangent of this angle is equal to the opposite side, 1.3, over the adjacent side, 0.8. Okay, now you may be wondering, how are we going to find this angle? Well, in your calculators, you're going to need to use something called the inverse tangent. So to get the angle, you're going to do the inverse tangent of 1.3 over 0.8. And once you do that, you can find the angle to be 58.4 degrees. We have a boat 300 meters away from a cliff, and it's looking up at an angle of 16 degrees. And using this information, we need to find the height of this cliff, which we'll call C. The first step is to take this situation and turn it into triangles. So 3 important points I see are the boat, the bottom of the cliff, and the top of the cliff. So it looks something like this. Now it's time to label. The boat is 300 meters away from the cliff. The cliff is C meters tall, and the angle of elevation is given to be 16 degrees. And hopefully this is becoming familiar to you. So we have an angle, and relative to this angle, we have the opposite side, C, and the adjacent side, 300. So once again, what do we have? Well, this is a problem involving tangent. So we have tangent 16 is equal to opposite C over adjacent 300. Now to find C, we can multiply both sides by 200. So C is equal to 300 times tan 16. And if you put that into your calculator, you'll get a height of 86 meters tall. So the cliff is 86 meters tall. So let's go ahead and label that for the next part. In part 2, this time, the boat came a little closer to the cliff. So we're told it traveled 75 meters closer, which means if it was originally 300 meters away from the cliff, now it's 300 minus 75, which is 225 meters away from the cliff. We need to find the new angle of elevation. So let's call that theta. So that's what we're trying to find. And now it's time to make our triangles once again. So our points are still the same. We still have the boat, bottom of the cliff, top of the cliff. Let's go ahead and label these. So the boat is 225 meters away from the cliff. The height of the cliff, which we found in the first part, is not changing. It's still 86. So this is an example where the first answer has to be correct. Otherwise, the second answer will also be incorrect. So it's very important to get that first part correct. Don't mess that up. This angle is theta, and we're trying to find theta. So once again, tan is involved because tan theta is equal to opposite 86 over 225 adjacent. And to get theta, remember, in your calculators, you're going to be inputting the inverse tan. So not the regular tan, but the inverse. So in your calculators, you're going to input something like this. The inverse tan of 86 over 225. And once you do that, you can find the new angle of elevation to be 20.9 degrees. This time, we need to find the height of the building CD. So let's go ahead and call that H. And let's split up this base right here, AB, into two parts. AD, which we'll call X, and BD, which we'll call Y. Now I want you to take a look at triangle ACD. So I want you to ignore completely the right side. Okay? So just this triangle right over here. We have this angle is 46 degrees and we have two sides. We have an opposite side and the adjacent side. So we can write that tan 46 is equal to the opposite h over adjacent x. And we can rearrange this for x if we just swap things around, and we'll find that x is actually equal to h over tan 46. Now you may be wondering, why did we even do this? Well, you are in for a treat. So let's do the same with the other triangle. So this time we're going to ignore the left side, and I want you to just look at triangle BCD. So first of all, because this angle is given to be 90 degrees, that means this angle is also 90 degrees because AB is a straight line. And let's just do the same thing for this triangle. We can write tan 55 is equal to the opposite side h over the adjacent side y. And if we rearrange it, we can get y is equal to h over tan 55. Because now we can actually finish the problem. We need to use the last piece of information that we haven't used yet. 82 meters. So we actually have that x plus y is equal to 82. Right? Because at the start, we divided this 82 into two parts, an x and a y. But now we have expressions for x and y all in terms of h. So we can take this and turn it into an equation involving only h. Since x is equal to h over tan 46, and y is equal to h over tan 55, we have this equation. And from here, we just have to solve for h. So the easiest way to do that would be to pull out an h and factor it like this. We're left with 1 over tan 46 on the inside and a 1 over tan 55. So in your calculators, to find h on its own, you're going to take 82 and divide it by this whole portion, 1 over tan 46 plus 1 over tan 55. But once you do that, you'll find that the height of our building is 49 meters. Okay, so we need to find the distance between two runners A and B. So let's start off by drawing the triangle involving the 24-degree angle. Now the 24-degree angle is actually going to person B if you follow this line. The 28-degree angle is going towards person A. So it would look something like this. And let's just fill this in. The observer is watching from a height of 80 meters. So this is an 80. And we'll call B's horizontal distance from the building to just be B. Now we can also draw A's triangle. Once again, the observer is observing from 80 meters. And let's say A is A meters away. And our angle is 28 degrees this time. So the way we're going to find this distance between the two runners is to take this difference, B minus A. So make sure you see how that will give us the distance between the two runners. Because what we're doing is we're finding how far B is away from the building, finding out how far A is from the building, and then that difference will give the distance between the two. So let's start with this triangle first. Since tan 24 is equal to 80 over B, then this means that B is equal to 80 over tan 24. In this triangle, tan 28 is 80 over A, meaning A is equal to 80 over tan 28. And the distance between the two, we've already said, is B take away A. So that's 80 over tan 24 minus 80 over tan 28. Put that in your calculator and you get a distance of 29 meters between the two runners. A child 0.5 meters tall is standing 0.9 meters away from a window looking up at a star. And the distance from the bottom to the top of the window is 2.1 meters. So we need to find the angle of elevation that the boy is looking up at the star. So first, we're going to draw our triangle. The child is 0.9 meters away from the window. We need to find the angle of elevation. And since the distance from the bottom to the top of the window is 2.1 meters and the child is 0.5 meters tall, that means the distance from the top of the window to the child's eye level is 2.1 minus 0.5 meters, which is 1.6. We have an angle, its opposite side, and its adjacent side. So again, we have tangent. So tan theta is equal to opposite 1.6 over adjacent 0.9. And then to find the angle in your calculators, you're going to punch in the inverse tan. So it looks something like this. Which ends up being an angle of 60.6 degrees. Eagle sitting on a sign 5 meters above the ground. Cliff 30 meters tall. Nest on top of cliff. Eagle looking directly at nest at an angle of elevation of 61 degrees. And we need to find out how far this eagle is from the nest. So we're talking about this length over here, from the eagle to the nest. We are not talking about this horizontal distance. That would be from the eagle to the cliff. But we're not looking for that distance. We want the distance from the eagle to the nest. So the first thing we need to get out of the way is if this cliff is 30 meters high and the eagle is 5 meters above the ground, then the remaining distance from the eagle to the top of the nest, so this vertical distance, well, that would be 30 take away 5, which is 25 meters. Now it's time to draw our triangle. So we have the vertical distance of 25 meters. The direct distance from the nest to the eagle, and then we have the horizontal distance. Now since we're trying to find the distance from the nest to the eagle, let's just call that distance x. And the eagle is looking up at an angle of 61 degrees. Okay, so this one is a little different. This time, we're trying to find the longest side, which is also called the hypotenuse. So we have an angle, and relative to this angle, we have its opposite side, and we're trying to find the hypotenuse. So which trig ratio relates the opposite side and the hypotenuse? Well, that's going to be sine. So if we spell that out, sine 61. And remember, so sine 61 is going to be the opposite side, 25, over x, the hypotenuse. Now we're going to find x. So we can move everything around to get x equal to 25 over sine 61. Punch that in the calculator and you get x equals 29 meters. I probably should have labeled that part A because there's a part B to this problem as well. So in part B, we're trying to find out how long it will take for the eagle to travel from this signpost to the nest if it flies at 4 meters per second. Well, luckily for us, in part A, we know the distance is 29 meters. So if the eagle has to cover a distance of 29 meters and it flies at a rate of 4 meters each second, then it's going to take a total of 7.3 seconds. Let's find out how long this bridge AB is. So to find the length of this bridge, we're going to find two lengths. This one, which we'll call A, and this one, which we'll call B. And then the length of the bridge will be A plus B. Now you may be wondering, why did we even do this? Well, this is a good idea because you'll notice we have two triangles. We have this one and we have this one. So we're going to look at them separately. So let's take this triangle and look at it more closely. So the triangle with side length A. Remember, if this angle is 90, then this angle is also 90 because it's a straight line. This angle is given to be 31, and then this side is 6. Okay, from here, relative to this angle, we have the opposite and adjacent side. Once again, we have tangent, and tangent 31 is equal to opposite 6 over adjacent A. This means A is equal to 6 over tangent 31. Nice. Let's keep that in mind. Okay, now let's move on to the other triangle over here, the one with B as a side length. So this is still 6, this is labeled B, this is right angled, and then the angle is 28 this time. But we still have the same logic. This time, tangent 28 is going to be equal to opposite 6 over adjacent b. Solve for b, and we get b equal to 6 over tan 28. And remember, the length of the bridge is going to be a plus b. So we can take a and b and add them together. So a plus b equals 6 over tan 31 plus 6 over tan 28. And this is what I would recommend putting into your calculator. I wouldn't recommend finding 6 over tan 31 and 6 over tan 28 individually, because you'll get a really weird decimal, and then you might have to do some rounding. The final answer might be off a little bit, so try to keep this in exact form and then round your answer at the end. Punch this in the calculator, you get a total length of 21 meters. So the bridge is 21 meters long. All right, let's find out how high this hot air balloon is from the ground. So I've gone ahead and labeled that H. So we can see we have two triangles, this one with the 45-degree angle and this one with the 55-degree angle. So this one's a little trickier because to use our trig ratios, we usually need two sides to relate to each other. So in both of these triangles, we can see we're not given the hypotenuse. We do know, however, that they share h, but we don't know how this distance of 100 is split up. We can't just assume that it's split 60-40 or 70-30, 45-55. So since we don't know how it's split up, but we need to do something in order to make progress, let's go ahead and label this unknown length x. So I'm just going to go ahead and do that. Then this remaining length is going to be 100 minus x, because this entire distance is given to be 100. Okay, now we have something to work with. So now let's rewrite everything in terms of trig ratios. So using this 45, we can relate it with h and x using tangent, because remember, tangent 45 is equal to opposite h over adjacent x. You'll notice I left a lot of board space here because we're going to need it. This one is pretty long, so hold on tight. But we'll get through it. Okay, that was this triangle. Now let's look at the other one, so involving the 55-degree angle. So this time, tangent 55 is equal to opposite h over adjacent 100 minus x. And now from here, if tan 45 is equal to h over x, then h is also equal to x times tangent 45. And in this case, if tangent 55 is equal to h over 100 minus x, then let's solve for h on its own. Why am I doing this? I think you'll see. H is just equal to 100 minus x times tangent 55. If h is equal to x times tangent 45, and h is also equal to 100 minus x times tangent 55, then x times tangent 45 is equal to 100 minus x times tangent 55. Okay, that's a mouthful, but I'm going to write it out. Now we're going to open up the right side with just basic distributive property. So x times tangent 45 is equal to 100 times tangent 55 minus x times tangent 55. Now we're going to bring all terms with an x to one side. So I'm going to move this minus x times tangent 55 to the other side. On the left, we're going to have x times tangent 45 plus x times tangent 55 equal to 100 times tangent 55. Let's pull out a common factor of x. So just basic factoring. Put these in brackets. Equals 100 times tangent 55. Sorry if that plus looks like a t. Hope that doesn't bother you too much. Okay. Now we're going to solve for x on its own by dividing both sides by tangent 45 plus tangent 55. Pretty crazy. So that's pretty crazy, right? X is equal to this gigantic thing. Now, we're not interested in finding x, so we don't really care what this value actually is, because that's not what we're trying to find. We're trying to find h, not x. And if we go back to the start, we know that h is equal to x times tangent 45. It's also equal to 100 minus x times tangent 55, but this first version is a little easier to find h, because all we're going to do is take this, which we know is x, and multiply it by tangent 45. So in the calculator, you're going to put something like this. H equals x times tangent 45. So it's going to be x, which is this expression, multiplied by tan 45. Sorry, actually, that looks like an x. You're right, that's the thing. Multiplication. Okay, I'm just going to put a dot instead. Okay, times tan 45. Punch that in the calculator and you'll get a height of 59 meters. Two monkeys looking up at a banana, and we need to find out how far these two monkeys are from each other. Now, if the monkey's eye levels are 2 meters above the ground and the banana is 5.2 meters above the ground, then that means this vertical distance of 5.2, take away 2, which is 3.2 meters, that's how far the banana is from the monkey's eye level. So this distance right over here. So even though it may not look like it in the picture, this is actually 3.2 meters. Just from here to here, okay? All right. Now, if you'll notice, we have two triangles. So there's one involving the 27-degree angle and the other one involving the 32-degree angle. So let's draw them out. So this is the first triangle, and this is going to be the one for the first monkey. So this monkey is looking up at an angle of 27. This vertical distance is 3.2 meters. Now, since we're trying to find the distance between the two monkeys, that distance is just going to be the distance from this monkey to this point where the perpendicular is dropped. Okay, so let's call that m plus the distance from this perpendicular to the second monkey, which we'll call n. So we're really trying to find m plus n. So let's go ahead and label this m. Now from here, tangent 27 is equal to opposite 3.2 over adjacent m, which means if we solve for m is equal to 3.2 over tan 27. Nice, that's the first triangle done. Let's repeat the process for the second triangle. So I'm going to draw that one here. Like that. Okay. Now let's label. This length is n. This side is still 3.2. And then the angle of elevation is 32 here. Now tan 32 is equal to opposite 3.2 over adjacent n, which means n is equal to 3.2 over tan 32. And the total distance between the two monkeys, we said, is going to be m plus n. M plus n is just 3.2 over tan 27 plus 3.2 over tan 32. So that's what you're going to input into the calculator. And you should get a final answer of 11.4 meters. So that concludes the first Cram video. I hope you enjoyed, and I hope you understand this concept a little better, because we got a lot of practice. And if you don't, just keep reviewing and watching over and over again until you get it. Now, we got a lot of practice in this video. We did many problems, but if you still want even more practice, I'm going to put up on the screen one final problem, which I'll leave as a homework problem. So you can do it at home on your own and write your answer or leave your solution in the comments, and I'll check them. So that concludes this video. Solve the homework problem. I highly recommend it. And yeah, have fun.